Hi there, this is Jacob Nash, and in this video we're going to be talking about dot product. So if you remember in the last video, we figured out how that we could add and subtract vectors, but multiplying them and dividing them, that was something different. Dividing, I mentioned we're not going to do. Multiplying, we can use what's called the dot product. Now, the dot product, there's a lot of different ways to go about explaining how that it works, but I am just going to cut to the chase and just tell you how that it works. So what it's going to be is, let's say that we have a vector u and vector v that exist in the same dimension. Then if we want to do the dot product of them, then it's going to be equivalent to u1 times v1 plus u2 times v2 plus so on to whatever the last one is, that's the components that match up. So that's actually, that's how that's going to work out. And then another thing is, if we want to know the magnitude of a vector, that might look like the absolute value. That's actually the magnitude. That's what that means. If we want to find the magnitude, it's actually going to be the square root of the vector times itself. Now, the way that that is derived really comes from the distance formula, but we don't really need to know that right now. But that's a couple things that we're going to end up using here. So whatever answer that we get from a dot product can tell us some information about how the vectors might be related to each other. We're going to just start out with positive or negative. So if the dot product is positive, then they're both going in the same direction. So that formula that I just showed you, if the answer that you get is positive, then those two vectors are going in the same direction. That kind of makes sense because the components are pretty much the coordinates, and if the coordinates are both negative or both positive, you're going to get a positive number, and that would make sense of why they're in the same direction. Now, if it's negative, then they are in different or opposing directions. But there's also a situation where we get 0. If that's the case, then they are going to have to be exactly perpendicular to each other. That's what that symbol means, in case you didn't know. So you could also get a dot product of 0. That's going to mean they're perpendicular because they aren't doing the same thing or different. It's exactly in between. So that means that there's nothing in common that they have. But one thing that you might be thinking at this point is, okay, now I know if it's positive or negative, if they're in the same or different direction. But what about the value itself of the dot product? So like, what would it mean if it's a bigger number versus a smaller number? So if our dot product is 20 versus 7, wouldn't we want to say that they're more related if it's a bigger number than if it's a smaller number? Or vice versa. If you're thinking that kind of makes sense, but that's actually not going to end up working, mostly because if the vector itself is super long, then of course it would make a bigger dot product, and it doesn't mean that they are closer in the same direction. So you have to think it's like confounding factors there. So if I draw that visually, these two vectors, they look like they're very closely related. And they are. They are doing a similar thing. But the dot product of the red and the blue is going to be bigger because that red one's long. It's got a big magnitude. So that means that the number itself is not going to be able to tell us that. But there is something that we can do, which is we can make a unit vector. That's going to help normalize these so that we say, too bad, make them all the same length, which is actually going to be 1, that's why it's called a unit vector, because it lines out the unit circle. So the way that we can normalize these and turn them into a unit vector to be able to do that is this formula right here. It's going to be the vector divided by its magnitude, because remember those absolute value looking things mean its magnitude. So that's what we do. And now, after we've done that, now we can say that a bigger number means more similar and a smaller number means less similar. So that's important. Now, all right, so trying to look here in my notes real quick. I don't know why I can't read that. Okay, sorry. So now we're going to quickly talk about the last thing in this video. This is just really supposed to be a brief concept review. But we can actually use the dot product in terms of an angle too. So if assuming those two vectors exist in the same dimension, we can actually say that their magnitudes multiplied by the cosine of an angle, which would mean our interior angle, that's going to be the dot product as well. And if they are perpendicular to each other, that means that theta is going to be pi over 2, which would also be 90 degrees. So that's important to know. We'll look at an example in a different situation, but so the dot product of them is going to be 0 if that's the case, because cosine of that value is going to be 0. It would make the whole thing 0. So as a result, we can say that the dot product is going to equal 0 if and only if, that's what this IFF means, if and only if they are perpendicular to each other. So that means the other way around is true as well. So that's the whole reason why I included this part right here, was to let you know that this red statement is true. So dot product of 0 is going to mean that they're perpendicular. The last thing that I'm going to talk about real quick, which we'll use later in these videos, is going to be a projection of vectors. So if these are the two vectors that we have, you might be asked to find this, which is almost like the shadow of u on v. That's going to be considered this. This is the notation for that. And the formula for this is going to be vector v times u times v, so the dot product there, and then the magnitude of v squared. So that's actually going to be it for this video. I apologize that if you're looking for more examples, I'm going to make a video of that later. Um, these videos that I'm making, I have to make it a little bit different than I have in the past because I'm working on multiple courses right now, 2 other ones in addition to this, and I don't really have the time to devote to all of them, you know, to where I could make a video like that's 50 minutes, you know, on each topic. I can't really do that. So this is really supposed to be just a brief review, kind of like what I did for Calc 2 Quick, if you saw that. So I completely understand if you find this video format purposeless, but this is really supposed to be a supplement to something that you'd see. So this is really just like a concept brief overview. So with that being said, thank you for watching, and I'll see you on the next one.